so this video we're going to talk about operations with polynomials. So we saw properties of exponents. Now we're going to take polynomials and write them, do sum and difference, product, and even look at GCF a little bit as we start to go towards factoring. All right, so we're going to just look at sum and difference real quick. These are the easiest, simplest, most straightforward. So I'm just going to jump into some examples. Let's say that we have a polynomial that looks like this. All right, so first of all, when we deal with polynomials, you can only add like terms. We can multiply anything. So if you had 2x times 2y, you'd get 4xy. And you could express that as such. But when we're talking about addition and subtraction, you can only add apples to apples. If you have 2 apples and 2 apples, you get 4 apples. If you have 2 apples and 2 oranges, you still just have 2 apples and 2 oranges. You cannot you cannot add them. So they have to be a common or like term here. So y to the third and y to the third, those are like terms. The y squared terms are like with y squared terms. That actually is the only one here. And then y terms will be like with other y terms, which this is the only one here. And then constants are like terms. So we're going to just, when it's addition of two polynomials, because of the commutative property, we can just rearrange this. We can just take away the parentheses and start adding. So this is basically saying the same thing as y cubed plus y cubed minus 5y squared minus 3y, and I'm just pulling these together as like terms. So I took this y cubed, that y cubed, minus y squared minus 3y plus 9 minus 4. I just kind of rearranged this so that it's in decreasing order. And that's generally how we represent polynomials. So now I can combine the like terms. I have 2 of these, so 1y cubed plus 1y cubed gives me 2y cubed. And then I have, these are not like terms, so I can just bring those down as they are. And then the constants, not a positive 9 and a negative 4, will give me a positive 5. And that's it. So with addition, it's really simple. You just get rid of the parentheses and start combining those like terms. And that's it. With subtraction, we have to be a little bit more careful because when we're subtracting, we're not just subtracting one term, we're subtracting the entire polynomial. So we're going to have to consider that. So here's an example. Okay, so when we look at this one, you have subtraction here. So again, we're not just subtracting this, we're subtracting this entire thing that's in this parentheses, this entire polynomial. So there are a couple of different ways that you could kind of think of this as, but what I like to think of this is like there's a negative 1 out here that I have to distribute. And that is the first thing you need to do. When you have a subtraction problem, we need to distribute that negative because we're subtracting that entire thing, which means we're subtracting each term. We do want to be very careful with the negatives here. A negative of a negative, for example, is a positive. So we just want to be careful with that. This one, we're not doing anything to. There's no negative out front. We're just going to bring that down in this next step. So that's 6a cubed minus 4a squared plus a minus 1. And then negative 1 times a negative 2a cubed is a plus 2a cubed. Negative 1 times a 3a is going to be a minus or negative 3a. And then negative 1 times the negative 5 will be a positive 5. So that is the first thing you need to do with subtraction. And then from here, we can just combine the like terms, just like we did with the addition, and then we'll be done. So I have an a cubed term here and an a cubed term here. So I'm going to add those together. 6 and 2 gives me 8a cubed. And then I have a negative 4a and a negative, that's a negative 4a squared. So negative 4a squared, I don't have another a squared term, so I just bring that directly down. And then I have, I'll just do like a little circle around these to show which ones are like terms. So I have a 1a and a negative 3a. Notice that negative stays with that. It's like it's minus, but that's the same as plus and negative. So positive and a negative 3a, positive 1 and negative 3a is going to give me negative 2a. And then I have this negative 1 and this 5. Again, the negative goes with that 1, so that's a negative 1 and a positive 5 gives me a positive 4. And that's it. All the like terms have been combined, and that is the answer to the problem. Again, the most important part of this, with the subtraction to remember is that you've got to distribute that negative, and then from there it's just combining the like terms. All right, then we have multiplication. multiplication, some of you may have heard of this or remember this. When you have a binomial times a binomial, you might have heard of FOIL. It's first, outer, inner, last. So you multiply the first, and then the outer, and then the inner, and then the last terms in each one. The way that I like to look at this, because FOIL only works for a binomial, meaning two terms times a binomial, I like to think of it as take the first term, distribute it to everything in the second one, like using the distributive property. Take the second term, distribute that to every term in the second polynomial. And we'll see that when we look at some where we have a trinomial. But we're just going to multiply this. Again, first, outer, inner, last, or you can look at it as distributing each one of those. So first, the x times the 3x. This is multiplication, so I'm going to get 3x squared. X times x is x squared. X times negative 4 is going to be negative 4x. 2 times 3x is 6x. And then 2 times a negative 4, that, again, like with the addition, that stays with that negative, or with that 4. So 2 times negative 4 gives me negative 8. And then I have some like terms that I can combine here. So I'm going to combine those. 3x squared plus negative 4x and 6x is 2x, and then minus 8. And that is the answer to that problem. So I've multiplied, and that's it, once you combine the like terms. All right, I mentioned that you might have a binomial times a trinomial. If you have that scenario, so we might have x squared plus 3x minus 6 times x minus 1. All right, so like I said, FOIL doesn't work with this one because the FOIL only works with there's a binomial times a binomial. So this one, I'm going to take this x squared and distribute it to everything. Now I'll take the 3x and distribute it to everything, and then the negative 6 and distribute it to everything. So I'm basically multiplying each term by each term in the other polynomial one time. All right, so x squared times x is x cubed. X squared times, and then x squared times negative 1 is negative x squared. And then 3x times x is 3x squared. 3x times negative 1 is negative 3x. Coming back to the negative 6, so now I'm going to distribute that. Negative 6 times x is negative 6x. And then negative 6 times negative 1, and negative times a negative will give me a positive 6. I do have some like terms that I can combine at this point. So I have the negative x squared and the 3x squared, and then I have this negative 3x and the negative 6x. So I'll bring down the x cubed. Combining these will give me a positive 2x squared. Combining these will give me a negative 9x, and then just bring down that 6. And that's it. All right. So that's multiplying. If you need to see more examples, you can look them up on Khan Academy, or Alex should have some other examples for you to refer to. But again, I know some of you tend to like to see videos like this and see them worked out like this. So hopefully this is helpful. All right, so then there's multiplying problems like these. This is the square of a binomial. So if you see this, do not be tempted to distribute that. That power of a product rule, that's power of a product, which means these would have to be multiplied in order to distribute that 2 to both of them. That does not work here. So do not, I see this a lot, where you want to make this x squared plus 9. That is not correct. That is not the right answer. So there are two ways that you could do this. You could look at this as, all right, well this just means x plus 3 times x plus 3. Because we know that square means multiply by itself. And then we could do the FOIL. So x times x is x squared. X times 3 is 3x. 3 times x is 3x. And then 3 times 3 is 9. And then combine those two middle terms, we'll get x squared plus 6x plus 9. That's one way to look at it. There's also a rule for this. The square of a binomial. Anytime you have a plus b squared, you will get a squared plus 2 times a times b plus b squared. If we attribute that to this example, the a in this case is equal to x, that x, and the b would be that 3. And you can see that if I just plug those in here, I'm going to get a squared, which is the x squared, so it's going to be x squared plus 2 times the a, which was x, times the b, which is 3, plus b squared, which is, in this case, 3 squared. So I'm just taking those and plugging it in. Anytime that you plug in, I would put in parentheses, because if this was like, for example, if this was a 2x, I wouldn't just be squaring the x, I'd be squaring the 2x. So I'd want to put that in parentheses here. That wasn't as big of a deal here, but I would encourage you, anytime you're plugging in, to plug in parentheses so that you can see that whole thing is being plugged in for that variable, so that you don't miss little things like that, like if it needed to be applied to both. All right, so x squared, that's just x squared. And then 2 times x times 3, that's going to be 6x. And then 3 squared is 9. And you can see we got the same answer as we did here. That will always work with a square of a binomial. That formula will always work for a square of a binomial. Okay, so those for now is operations with polynomials. We are going to get into factoring in the next video. So in this video, I'm going to give you a brief little introduction to the greatest common factor, or the GCF. So the GCF is kind of what it sounds like. It's the greatest factor that's common to both of the terms, or if there's multiple terms, it's common to all of the terms. So it's the largest factor that goes into all of the terms that we're dealing with. So I'm just going to show you some simple ones to kind of start off with. So let's say that we have 2x squared and 4x to the 6th. All right, the greatest common factor. Now, factor is something that goes into or divides into. So what is the biggest number that evenly goes into 2 and 4? And that would be 2. That's the biggest number that divides evenly into both of them. 2 goes into 2 once, 2 goes into 4 twice. So 2, and notice I'm looking at the coefficients first. I'm kind of keeping those separate, and then I'm going to look at the x's separately. So the GCF of 2 and 4 is 2. And then x squared and x to the 6th, if you think about what these mean, this means x times x, and this means x times x times x times x times x times x. There's 6 of them. How many are in common? Now these are each factors. There's 2 x factors here and there's 6 x factors here. How many of them are in common to both of them? 2. There's 2 of them here, there's 6 here, there's 2 that you can pick out that are in common. So that would be your GCF from those x terms. So and then we can just take what you got for the GCF and the coefficient and combine that, the product with the variable term. So that's basically how you find the GCF. Some of these you will be able to just kind of look at and determine what that is. Here are the shortcut. If you don't know, so here's looking at it for 2 different numbers. If we wanted to find the GCF for these 2 numbers, this is kind of the long way. Like if you're looking at it and you're like, I have no idea what the GCF of this is. This is the way that you can like no fail kind of figure it out. What we're going to do is we're going to do a factor tree for these, which basically means just take them into their prime factors. We're going to do prime factorization. So we're going to break it down as much as we can. So we're going to look at 210 as, I know it's even, so I know that 2 goes in there. So 2 times 105. And then 2 is prime numbers. I can't take anything else in there. So I'm going to take this 105. Well, I see that 5 goes in there. So 5 times, and that would be 21. 21 is not prime, 5 is. So I'm done with the 5. 21 would be 7 times 3. All right, so this prime factorization is 2 times 5 times 7 times 3. That is called a prime factorization. If there was like multiple, if I had a 3 and a 3, then I could write 3 squared. But that is called the prime factorization for that. I'm going to do the same thing here. It is an even number, so I'm going to take 2, and then that would be 84, 2 times 84. And then take this 84, 2 goes into that again, that would be 42. And then 42, you could break this down into 2 and 21, or you could do 6 and 7. I'll do 2 and 21, and then 21 would be 3 and 7. So those are the numbers that multiply, the prime numbers that multiply to be 21. So once you get down to all prime numbers, you can't divide them up anymore, then that's it for a prime factorization. All right, so I could write this, I had 2 times 2 times 2 times 3 times 7. And if you want to test this, you can multiply this in your calculator and you will end up back at 168. This would be 2 to the 3rd power times 3 times 7. Now I'm going to compare these, and what I'm looking for is the greatest common factors, so the most that are common of each of the factors. So notice that I have 2 here, I have 3 of them here. The most that occur that are in common between the 2 is 1. I have this 1 here. So the GCF is going to be 2 times, and then I have a 5. I don't have a 5 in common here. There is no 5, so I don't want the 5. Then I have a 3. I do have a 3 there and a 3 there. Just 1 is in common. So 2 times 3. And then the only other one that I have there is a 7, and I do have one of those in common as well. So the GCF here is 2 times 3 times 7, which is 6 times 7, or 42. So your answer to that question, that would be your GCF is 42 for those two numbers. Now, most of the problems that you see won't have huge numbers like that, but you can do a prime factorization, and again, it's what's in common, the greatest number that divides evenly into both of them. To test it, if you want to be sure, does 168 evenly divide 42? Yes. Does 210 evenly divide 42? You could do that in your calculator and it will work out. So that is how to find the GCF. I'm just going to show you a little bit more here, and then we'll go into factoring in the next video. Okay, so here's another example. We're going to find the GCF of these numbers. Or these terms, I should say. All right, so I want what's in common. Greatest common factor between all of them. What is the biggest number that goes into 8, 16, and 10? It's 2. 2 is the biggest number that divides. If you're thinking, okay, well, 4 or 8 goes into both of these, yes, but they don't go into 10. So it would need to go into all 3 of them. So 2 is the biggest number. Then I have x squared, x to the 4th, and x cubed. The most that are in common, there are 2 here, 4 here, and 3 here. You're going to take the lowest exponent because that's going to be what's in common. So it'll be the x squared. And then y to the 5th, y squared, and y to the 3rd, same idea there. It's what's in common. There are y squared can go into each one of those, can divide in evenly into each one of those. So that is what I'm going to take. And you are probably noticing that is always the lowest exponent, and that will always be the case because that's what will divide it evenly in there. So that is the GCF for this set. All right, you're going to see more of this when we get to factoring, and that will be in the next video. But that's it for this one. All right.